Mystery model fractions. Let's take a look here at this little fraction. You can see that we have 4 blocks colored in. We have over here on the left side, you can see we have sections and pieces, and then over here on the right we don't have anything cut in. And we need to figure out the math problem and the answer to that math problem that represents this mystery model. So if you have watched the 5.8 and 5.9 videos, you have seen how you can represent multiplication of fractions through pictures. And that's what we are going to do. So this is like the final step. This is like the challenge problem when using pictures to model multiplication. All right, so the first thing that I see is that it looks like I could probably extend this line out, and likewise down here. After I do that, it seems like now it looks a little more manageable. So if I label the sides now, let's label our pieces. Again, you can label the spaces or the lines. I like to label the spaces. It seems to help my kids in my class a little bit better. So you can see the left side represents thirds, and the columns represent fourths. And now what I have is, you can see the dimensions. Just like the area model, you can find the dimensions. The dimensions would be, it's 2/3 by 2/4. You can tell that because it goes to here, which is our 2/4, and then it goes to 2/3, which is here. So we know that our dimensions are 2/3 by 2/4. Now, again, we write that as a multiplication problem, and we can get 4/12, which if we look at our picture, that makes sense because we have 4 colored in, and there are 12 total rectangles represented. So it looks like our answer would be 4/12, or we could simplify by dividing the top and bottom by 4 and get 1/3. Let's take a look at another one. Okay, same idea. Now we just have to kind of finish the drawing here. We're missing some lines. It looks like we could extend a few, do a little bit of labeling, and we'll be good to go. So first thing that I see that we should probably do is, let's extend these out. That seems to complete the picture. And now we need to list its dimensions. So again, I'll label that down here. We have 1, 2, 3, 4, 5, so I know it's going to be fifths. 2 fifths, 3 fifths. And then going tall, we have 1, 2, 3, 4, so that is cut into fourths. All right, there you go. Now it's a matter of finding its dimensions. So when I say dimensions, that means its length and its width. So width usually means wide, like left to right, and length is usually the more confusing one to remember, but if width is left to right, then we know length is up and down. So its width, left to right, starts here and goes over to 3 fifths. Its height is 2/4. Now we know that area equals length times width. We multiply those again, 2/4 times 3 fifths, and we get 6/20, which we can simplify because they're both even, and we get 3/10. So our answer is 6/20, so we can verify that back with the picture. Does that make sense? Once we added those lines in, yes, we have 6 colored in, those brighter blue or the darker blue. That's our numerator, and our denominator, the 20, comes from the 20 individual squares or rectangles, depending how good your picture is. There'll be 20 rectangles on the bottom. Now the final thing, this is to help you with the homework for lesson 5.10, is a little refresher reminder on how to add and subtract fractions. All right, the key for both of these, you can see we have an addition problem, we have a subtraction problem. You must have common denominators. If you do not have those, it's not going to go well. So let's start by finding common denominators. 2/3 and 3/4 common denominators we get by cross multiplying. Then we multiply our denominators together. So you can see how I didn't worry about the whole numbers at that point. I just found my common denominators. So now I'm going to rewrite my problem. Plus 3 and 9/12. Now that the bottom numbers are the same, now I can add. So whole number plus whole number, I get a 5, and then I get 8/12 plus 9/12 is 17/12. Now, though it would be nice to stop there, we probably should simplify. Okay, so I'm going to pay some special attention to our 17/12. We need to split that up. All right, that's improper. So we are going to break that up into 17/12 equals 12/12 plus 5/12. Now, there's a reason why I split that the way I did, because this equals 1. So if I rewrite my work here, I now have 5 plus 1 plus 5/12. I took my 5 from my original answer, I added that 1 that I just filled in there, and then I cannot forget about my rest of the fraction. So 5 plus 1 is 6 and 5/12. Now let's take a look at subtraction. Subtraction, we are going to follow much of the same setup here. First thing we need is we do not have common denominators, so we need to get them. So we are going to take them, cross multiply. 48 over 56. Let's rewrite. And now we have 4 and 35/56 minus 1 and 48/56. Oh, looks like we have an issue here. Our issue is that we cannot take 35/56 from 48/56, so we will need to borrow. Now, since our denominators are huge, there is an option to do times plus, turn them to improper, subtract across, and simplify. Go ahead and do that. I'm going to just simply show borrowing by taking 1 from the whole number and adding it to the fraction. So I'm just relocating, if you will, my 1. So now my new fraction is 3 and 35 plus 56. Let's make sure we show our work here. It's 91. Wow. It's a big numerator. So there's our new problem. Now it looks like we can handle this. We have 3 and 91/56 minus 1 and 48/56. We can subtract our whole numbers, which gives us 2. And then we have 91 minus 48. 91 minus 48. A little borrowing here. And we get 43 over 56. It was a lot of work, but that is our answer there. So we get 2 and 43/56. The key to success whenever you're adding or subtracting mixed numbers is common denominators. It's a must. And then with subtraction, you also have to make sure that you borrow properly. Hope this helps.